Hello learners, welcome to this course on Embedded System Design using PIC16F877 Microcontroller. So in this tutorial, I will be discussing about how to interface LED with PIC16F877 Microcontroller. Then we will try to do some logic on this LED interface with PIC16F877 IC. So here in this tutorial, I will be using two softwares. One is Integrated Development Environment IDE, so which will be Micro C Pro for PIC compiler. So this compiler can be used to write a C program, embedded C program, and this C program can be converted into a assembly language program as well as an opcode file. Then we will try to build a circuit using a Proteus 8 simulator. After building the circuit, we try to import the opcode file or hexadecimal file which we have created in the compiler onto the circuit. Then we try to check the logic of operation. So as a first program, we are going to do a simple LED interface with PIC16F877 microcontroller. And LED is a two-terminal device which has an anode and a cathode. So the anode can be connected to a plus 5 volt supply and cathode can be connected to a ground. So by just simply connecting this anode and cathode to a supply, we can able to make the LED to glow. So here in this program, I am going to interface a LED array. Around 8 LEDs we are going to connect to port D of your microcontroller. We have 5 ports on this PIC16F877 microcontroller: port A, port B, port C, port D, port E. So in port A, I have 6 lines, A0 to A5. Port B, I have 8 lines, B0 to B7. Port C, I have C0 to C7, 8 lines. Port D, we have D0 to D7. And port E, I have 3 lines, E0 to E2. So here I am going to use a port D lines RD0 to RD7 connected to the anodes of the LEDs, and cathode we are going to ground it. So in order to do some logic on this LED array, we need to configure the port pins. So each port pin of your microcontroller can be configured in either in input mode or in output mode. So to do the configuration part, we have a data direction register associated with each ports. So for example, there is a data direction register TRIS-D associated with port D. Same way, TRIS-A for port A, TRIS-B for port B, TRIS-C for port C, and TRIS-E for port E. So each port in my microcontroller has a data direction register, which defines whether we are going to send the data out from a microcontroller or we are going to get the data into the microcontroller. So this is a 8-bit register. Each bit is related to a particular port pin. For example, the LSB bit of your TRIS-D register is associated with RD0 pin. Same way, first bit of your TRIS-D register is associated with RD1 pin. Same way, MSB bit of your TRIS-D register is associated with RD7. So if I set a value of 0 to this bit, then the corresponding pin will be set as an output pin. If I put the value to be 1 in this bit position, then the corresponding pin will be configured as an input pin. So thereby the data direction can be specified, whether we are going to get the data into the CPU or we are going to get the data out of the CPU or microcontroller. So this data direction register is used for configuring our port lines as either an input pin or an output pin. Then we have a buffer register. So each port has a buffer register. For port D, it is called as a port D. Same way, port A, port B, port C, and port E are available for each ports. Again, as usual, each bit is associated with a particular port pin. So for example, LSB bit of port D register is associated with RD0. Same way MSB bit of port D register is associated with RD7 pin. So a logic 0 to the particular bit means the corresponding pin will be at 0 volt. A logic 1 to the bit will means the corresponding pin will be at logic 5 volt. So using these two registers, we try to write a program, embedded C program, and we try to do a toggling of LEDs. So in order to start the program, we have two parts. As I said, we need to construct a circuit using Proteus 8 Professional. Then we have to write a code on Micro C Pro for PIC, compile it, convert it into a opcode file or hexadecimal file, then import that hexadecimal file onto the microcontroller which we have built in the Proteus 8 Professional. First, let us start with building a circuit. So for that, let me open Proteus 8 Professional. So I am going to create a new project. So select a folder where we are going to put the projects. So I am going to put my project in downloads, work, PIC, and in Proteus I am going to put the project. So give a name for the project. Since we are doing LED, I am putting it as LED, and the project name should have an extension of .pdsprj. Press next. So we need to select the schematic where we are going to build the circuit. So for that, I am going to select a default schematic. Press next. So this software, Proteus Design Suite, can also be used for creating the PCB layout. So right now I am not going to concentrate on a PCB layout, so I am going to leave as it is. Do not create a PCB layout. Press next. And we are not going to work with a certain firmware like 8051 or ARM processor, etc. So I am going to leave it as it is. Press next. So we have selected only the schematic, layout and firmware are not selected. Press finish. So this is the schematic where we are going to build the circuit. And for building the circuit, we require the components. For selecting the components, on the left hand side, you can see P for pick the devices. Click on that. Here this window will open. So here we can select for our IC. So select the components. So we require a PIC16F877. So here you can see there are two versions available, PIC16F877 and PIC16F877A, and its features are also shown here. For example, in case of PIC16F877, it has a 8 KB of code memory, 368 bytes of data memory, 256 bytes of EEPROM. Then it has port A to port E ports, 2 capture, compare and PWM modules. PSP is for parallel slave port to send the data parallelly. It has 3 timers. Then MSSP module is for I2C protocol as well as SPI protocol for serial data transfer. Same way USART is a universal synchronous receiver transmitter, and we have a 10-bit ADC with 8 channels. So this shows the features available in your PIC16F877. So we are going to select this IC PIC16F877. So I am going to double click on that. So it gets added to our list. Similarly, I require a crystal oscillator. So crystal, then a crystal symbol is represented here and its PCB layout is also shown here. So here I am going to double click on that, so it gets added to our list. Then I need to have a bar graph LED. So bar graph LED is something like an array of LED which we are going to use in our program. So I type it as bar graph. So we have different colors like green color, red color. So I am going to select a red color. It gets added to our list. Then I also require resistors. Add a resistor to the list. Capacitor add a capacitor to the list. Then I also require a switch for reset operation. So switch, I'm going to add it to the list. So these are some of the components which I require for building the circuit. So after selecting the components, press OK to come out of this PIC devices window. So now we have selected the components for building the circuit. Now we are going to build the circuit inside this schematic. So we have to build the circuit within this blue box. So first let me select the PIC microcontroller, then put it onto the schematic. So just by clicking on the schematic, I can select a position where I am going to put the IC. So here you can see this is a PIC16F877 microcontroller. And I am going to connect a bar graph LED to port D. So select the bar graph LED, place it onto the schematic. So here pin number 1 to 10 represents the anodes, pin number 11 to 20 represents the cathodes. So here I have 10 LEDs in this bar graph. So I can connect each port pin. D0, I am going to connect it to pin number 1. This is the first LED. Same way D1 to pin number 2 of LED 21. So like that I am going to connect all the LEDs to the anode of your bar graph LED. So I have connected all the port D pins RD0 to RD7 to pin number 1 to 8 of your LED. I am going to use only 8 LEDs in this bar graph. Then the cathodes I need to connect it to ground. For selecting the ground, go to on the left side you have lot of icons. In that you have a terminals mode. So select terminals mode, you will find power as well as ground. So select the ground, place it onto your circuit. Then connect the ground to the cathodes of your LED. So connect all the cathodes to the ground. Once connection is done, we have connected the bar graph LED to our port D. Now we need to connect the oscillator onto the circuit. So for selecting the oscillator, again go to components mode, which you can find on the left side. Components mode, select the crystal. I can rotate this crystal by pressing these icons, either in clockwise direction or anti-clockwise direction, or I can do horizontal flipping or vertical flipping. So I am going to do a clockwise rotation, place it onto your circuit. Connect the crystal to the oscillator pins of your microcontroller. Oscillator 1 and oscillator 2 are the pins for your microcontroller. Connect it to the oscillator pins. Then to produce a stable waveform, we need to connect the capacitors with the crystal. So I select a capacitor. Again I am going to rotate it and place it onto the circuit. So we require 2 capacitors. Connect these capacitors with the crystal. Other end of the capacitor, we connect it to ground. So again go to terminals mode, select ground, place it onto your circuit. So connect the capacitors to the ground. Then we need to select the value for this crystal. For in our program we are going to use 10 megahertz. So this microcontroller can support up to 20 megahertz we can connect. So I am going to select the crystal frequency. So right click on the crystal, edit properties. Here you can set the crystal frequency. So I am going to use 10 megahertz. Press OK. Similarly, I can change the frequency capacitor values. Right click on the capacitor, edit properties. I am going to change it to 33 picofarad. Same way this capacitor value is also changed to 33 picofarad. Press OK. So we have done with the oscillator circuit. We have to do the reset circuit. So again go to components mode, So here you select the resistor. I am going to rotate it and place it onto my circuit. Then a switch, I am going to place it onto the circuit, connect the resistor with the switch. Other end of the switch, I am going to connect the ground. So again go to terminals mode, select ground, put it onto your circuit, connect it to the switch other end, and power, connect it to the one end of your resistor. Then the intermediate point, we need to connect it to the memory clear pin. So memory clear pin is selected, it is connected to the center point of your resistor and switch. So here by default what happens, this memory clear is an active low signal. So a logic 0 to this pin will reset the microcontroller. So by default this pin will be at 5 volt. Whenever I close the switch, this pin will go to 0 volt, because since it is connected to ground, the current will flow from the supply to the ground. So whenever the switch is closed, this pin will become logic 0, then the microcontroller will be in a reset state. When I release this, this pin will be at 5 volt, so a reset operation will not be applied. So this is a reset circuit. So this is a mandatory circuit. The oscillator circuit and the reset circuit are mandatory circuit for the proper operation of our microcontroller. And other peripherals which we connect, or depending upon our application, we can connect those peripherals. But this oscillator circuit and the reset circuit are mandatory circuits. So we have built our circuit. We have connected the bar graph LED to port D of your microcontroller. Now let us save the project. We have saved the project. So now we are ready with the circuit. We need to write the code for doing the operation. So for writing an embedded C program, we go to Micro C. Micro C Pro for PIC. You can download the software from the website microe.com. So there you can download this software and install it. So here also we need to create a new project. So select new project. So it asks for whether you are going to use a TFT or a standard project. We are going to do a standard project. Press next. So here you select the location where we are going to put our programs. So I go to downloads, in work, PIC in Micro C folder. I am going to put my project folder location. Then here you have lot of ICs supported by your PIC Micro C compiler. So you have to select the appropriate IC. So here we are working with PIC16F877. So you select the PIC16F877 from this list. Right, PIC16F877 microcontroller. Then we have to define the oscillator frequency. In our circuit, we have used 10 megahertz oscillator frequency. So I am going to use the same 10 megahertz here. So there should not be any mismatching between the oscillator for building the circuit and using that oscillator frequency in your program. So both should match. Then I am going to give a name for the project. I am going to give the name as LED. So here we do 4 things. One is selecting the project folder location, giving a name for the project, selecting the microcontroller, and selecting the frequency, crystal frequency. Press next. So right now we don't have any C program files with us. So I am going to leave as it is. Press finish. Now this window is where we are going to write our program. So let us save this program as LED with an extension .c. Save. So this is the location where we are going to write our embedded C program. And here you can see the controller which we have selected and the oscillator frequency which we have used. And here you can find the project manager which lists the current working project. So here you can see when I expand this, you can see the source file So right now the project contains led.c, which is this file. And we have libraries associated with the compiler. So micro C libraries, system libraries. So here it has lot of libraries like ADC library, math library, EEPROM library, LCD library, keypad library, for keyboard interface, for UART, SPI. So like that, for many functionality of your microcontroller, the libraries are different. So you can tick whichever library you want to use it for your operation. So right now we are not going to use any library. So I will leave it as it is. And this is the location where we can find the variables, functions, everything. And here we have the output window where it shows whether our program has any errors or not. While compiling, it will show any errors or not in the program. So let us start with the program. So by default, this function will be obtained when you open a project. So void represents the return type of your main function. So we are not going to return anything, so it is empty. Same way, we are not going to provide any input arguments to the main function, so it is also empty. So first we will start with the program. First step is we need to say our port D is used as an input port or an output port. Since we are going to connect a bar graph LED to port D, we need to define it as an output port. So that is defined using the tris function. Tris D equal to 0x 0 0. So what is the 0x represents? It represents, it's a hexadecimal number, which means it will be represented as 0 0 0 0 0 0 0 0. So each bit associated with each port pin. So 0 means it will be configured as an output pin. 1 means it will be configured as input pin. Since our LED is an output device, we need to configure it as output pin. So I am configuring all the port D lines, RD0 to RD7 as output pins. So that is why we specify it as 0x00. So now let us start with a while loop. While of 1. So I want the program to run continuously. So I put a while statement, check for the condition. Condition is always true. So we are going to execute the program infinite number of times. So within this open and closed parenthesis, I am going to put the logic. So I am going to set it as port D equal to 0xFF, meaning, so I am going to make all the port D pins to be FF in the sense it is 1111 1111. So we provide a logic 1 to the port pins, which means 5 volt to the port pins RD0 to RD7. So 1 represents 5 volt, 0 represents 0 volt. So what happens when I execute this? All the LEDs connected to port D will be in on state. It will be glowing. So in order to see this output, we need to retain this value for some time. So that is done using the delay function. Delay underscore ms. So we create a delay of 1000 milliseconds. So 1 second delay. So each statement should end with a semicolon. So we create a delay of 1 second. One second is created. Then I am going to change the logic here. Port D equal to 0x00, which means I am going to switch off all the LEDs. So I put 00000000, which means we switch off all the LEDs. Again, I am going to retain this value for some time. So delay underscore ms 1000. Since this program is in while loop, again the LED will go to on state for 1 second, then again it will come to off state. So this will continuously run. So first what we are doing, we are configuring the port to be an output port, then we are defining the logic. We are switching on all the LEDs connected to port D for 1 second, then all the LEDs connected to port D goes to off state. Since it is in a while loop, this runs continuously. So we have done with the program, so we can save this program. Now we need to convert this embedded C program into a opcode file, hexadecimal file, which will be understood by your microcontroller, because the C program will not be understood, right? So the microcontroller, it accepts only the data in terms of a hexadecimal format or a binary format. So we need to convert this high level language program into a machine level language program. So to do that, either I can go to build and press build, or we have a shortcut icon here, build. So this I can click, and here you can see right now we don't have any errors. So here in the output window you can see we are using PIC16F877. It has 352 bytes of available RAM, totally 358 bytes, and some bytes have been used. So remaining RAM memory is shown here. Same way remaining ROM memory is also shown here. So used RAM is about 1%. Free RAM is 99%. Same way for ROM also, what is the used ROM as well as free ROM. So if I have some errors, for example, intentionally I will remove a semicolon here. Let us save the program. Again, let me do a build operation. You can see it shows an error. It shows expected, semicolon is expected, but found the parenthesis. So we can identify in which statement we have the errors, and we can do a correction also. So put semicolon, save, and build the circuit. So now we don't have any errors. So it is fine. So now let us go and see the hexadecimal file. So let us go to the work folder. In PIC, I have micro C. So here you can find a hexadecimal file. So our C program has been converted into a hexadecimal file or an opcode file. So let us open this file and see. So let me open with a notepad. You can see this is the opcode file. So this is the hexadecimal file of our program. Whatever we have written in our C, that has been converted into an opcode file. So this opcode file only we are going to put it onto the program memory of your PIC microcontroller. So now let us put this hexadecimal file onto the PIC microcontroller in Proteus environment. So let us go to the Proteus environment. So I have to import that hexadecimal file. So for importing, right click on this microcontroller IC, go to edit properties. So here you have an option of program file. So select the program file, go to the location. In micro C folder, I have this hexadecimal file. You can see here, it's a hexadecimal file. Select. So we are importing the hexadecimal file onto the microcontroller. And also we have to set the clock frequency for the processor, which we have set it to 10 MHz. Press OK. So we have imported the hexadecimal file onto the microcontroller. Now we have to check the logic, whether it is working properly or not. So here you have a play button on the top bottom left corner. You have the play button. Press this button. You can see all the LEDs are glowing and it goes to off state. So there is a toggling of LED happens. Now let us change the logic and visualize the result. So again, let us go to the program. Now let me change it as AA, which means I am going to do 1 0 1 0 1 0 1 1 0. So alternate LEDs are going to glow. Okay, every alternate LED is going to glow, and I am going to change the logic here also to 5 5. So 5 5 means the LED which were in on state, it goes to off state. 0 1 0 1 0 1 0. So the LED which were earlier on, now it goes to off. Same way earlier the LED is in off, now it goes to on. So we are going to make a change of this logic. So let us save the program, compile it again to create a new X file for the new program. So again, let us go to the Proteus environment, load the hexadecimal file. So LED, press OK. So now we have loaded it. Press the play button to see alternate LEDs are glowing. Right? There is a toggling of LED, alternate LEDs. So like this, we can check our program whether it is working properly or not using the simulator available. To stop the simulation, you can press the stop button here on the bottom left corner. Press the stop button. So that is how an LED is interfaced with your microcontroller, and we try to see the logic change in our LED interfaced with your microcontroller. Thanks for watching. Please subscribe for more technical learning. Thank you.